Hello, okay, boys. Welcome again for the lecture of industrial fluid power. I hope you all have watched the first lecture in which we studied some important hydraulic circuit. So, from class second shift and A division, I think all the students have watched the video on YouTube. Most of the students has given their attendance, and most of the students are also given some good comments related to the lecture that we deliver. It was the first attempt, so I think everyone understand the meter in hydraulic circuit. Today we are going to see the two important circuits which are also the flow control circuits, that is meter out hydraulic circuit and bleed off hydraulic circuit. So before starting the actual syllabus of the industrial fluid power, I once again appeal to all my dear students that please be at home, remain at home whenever you are. If you are in your village, if you are out of Aurangabad, so please take care of yourself, be at home, don't move outside, and also convey to your all friends, relatives to remain in the home. So I hope everybody will take the care, lot of care. Now yesterday what we have seen, we have seen the meter in hydraulic circuit. And what is meter in hydraulic circuit? Meter in hydraulic circuit is nothing but it is the circuit, hydraulic circuit, which is used for controlling the speed of the actuator. And in meter in hydraulic circuit, as you know that we are providing the flow control valve. And which type of the flow control valve we are using? We are using pressure compensated flow control valve with integral check valve, or we can call it is the integral non-return valve, right? So that valve we are using at the inlet of the actuator, and therefore the forward motion of the actuator is controlled, that it is slower forward motion of the actuator. And when the return motion take place, what happens? Whatever the oil is coming from the A port of the actuator, that oil will freely flow through the integral check valve, or which is known as the non-return valve, and therefore the return stroke of the actuator will be faster. Therefore during forward stroke we can control the speed. And in meter in, we are connecting the flow control valve at the inlet of the actuator. Understand? Now today we are going to see the second important hydraulic circuit, which is known as meter out hydraulic circuit. The name itself is very clear. Meter out means what? I am providing the flow control valve at the outlet of the actuator, whatever may be the actuator, either it is the linear actuator or it is the rotary actuator. At the outlet of the actuator, when I connect the flow control valve, it is known as the meter out hydraulic circuit. Understand? Remaining things will remain same. So let us see that how the meter out hydraulic circuit will work and how we are controlling the speed of the actuator by using the meter out hydraulic circuit. So okay boys, this is the circuit diagram of meter out hydraulic circuit. Now as you can see here in this circuit diagram, what are the important components? Same. So this is the reservoir where the hydraulic oil is stored. This is the filter. The function of the filter is to filter the hydraulic oil and remove dirt, dust and dirt particles, and clean oil is sent to the pump. So this is the pump. This is again the unidirectional constant discharge hydraulic pump. This is the prime mover, or we can call it the electrical motor, which is used for moving the pump. Then at the outlet of the pump, what happens? This is the pressure relief valve is there. The function of the pressure relief valve is to control the system pressure, and whenever the system pressure is higher, then this system pressure is released to the reservoir through this pressure relief valve. So this is the pressure gauge which measure the system pressure. This is the pressure gauge is provided here. Then 4x2 direction control valve is provided here. This 4x2 direction control valve, there are the two positions of the direction control valve which is having the 4 ports. So that is the P port, this is A, this is R port, and this is the B port. So again here this is the P port, the pump is connected here, this is connected to the B port, this is A port of the actuator, and this is going to the reservoir. Now you can see here, and this part is known as the actuator. Our double acting hydraulic cylinder is there, that is the actuator. This is the A part of the actuator and this is the B part of the actuator. Now you can see the difference. In case of meter in hydraulic circuit, this pressure compensated flow control valve as provided at the inlet of the actuator. But in this meter out hydraulic circuit, you can see the pressure compensated flow control valve is provided at the outlet of the actuator. Now how the speed of the actuator is controlled? By using the meter out hydraulic circuit. Now what happens, let us consider this position, right? Now in this position, whatever the lectures we have taken in the classroom, in that this position was our second position, right? And this was our first position. We will start from this position. Now if suppose the direction control valve is in this position, so in this position what will happen, the pump will be connected to the A end of the actuator. So oil will flow from here and it will go to the A end of the actuator, and this B end of the actuator is connected to the reservoir. So whatever the oil will come from this will come to the reservoir. This is position number 1 of the direction control valve. Now what happens in this position? As you can see that the pump is deliver some amount of the pressure and the hydraulic oil. That same amount of the hydraulic oil will go from P end to the A end, and here there is no restriction. This is the free flow. The oil will flow freely. Whatever the amount of the oil is coming from the pump, that will go to this end, and the piston will start, or the actuator will start moving into the forward direction. But when the actuator is coming into the forward direction, what is happening here? You see here, at the outlet of the actuator, the flow control valve is provided, and this flow control valve is having the integral check valve. This is the integral check valve. Check valve can be called as non-return valve, because if you can see from here, when the oil will come this direction, the oil will not go, right? So from this check valve, the oil will not come. Only the oil will come from this flow control valve, this part of the flow control valve, right? Now what happens when the pump is connected to A end? As I already mentioned you that the oil will flow from this end, the piston will start moving into the forward direction, but there will be the some amount here already from previous stroke. There will be some amount of the oil here. That oil will start now flowing through the flow control valve, and as this flow control valve is adjusted, this is not 100% open. You know that flow control valve we will not always keep the 100% open. We will reduce it like 90%, 80%, 70%. So suppose what happens, now I set this flow control valve at 70%. So what will happen, whatever the oil is stored here, that same amount will not flow freely through this flow control valve. The oil will get some restriction to the flow, means the oil will get some resistance, because this flow control valve is at what setting? Say 70%, right? It can be at any, depending upon how much speed control you want. So now for example, let us say it is of 70%. So it will have some resistance, and as this will have the resistance, the opening will be small. Therefore what will happen, this oil will not come quickly through this flow control valve, and the oil, as the oil is not come quickly, the motion of the actuator will become slow. You understand why the motion of the actuator will become slow? Because though from this side the oil is going, 100% oil is going, but whatever the oil is coming out of the actuator, as I have provided the flow control valve, that oil is getting some restriction, and therefore this oil will not flow easily, it will have some resistance, and therefore the forward motion of the actuator will be slow. Understand? This will happen in the first position. Means what I did the same thing what I did into the meter in hydraulic circuit. In meter in hydraulic circuit also I have controlled the speed during the forward stroke, but in that case the flow control valve was fitted into the inlet. Understand? Here also I control the forward motion of the actuator, but here I kept the flow control valve at the outlet of the actuator, and here I provided some restriction because I said the flow control suppose I said 70%. So 30% flow I restricted, and therefore the forward motion of the actuator became slow. Understand? This is the first position. Now what happens, the slowly the piston move here, actuator move here, and the actuator came here. The first stroke is completed. Now there is a time to change the direction of direction control valve. Now operated the lever, so whatever may be here, the push button will be there, lever will be there, foot operated lever will be there, solenoid coil will be there. This can be operated by the hydraulic line, this can be operated by the pneumatic right, whatever the means I am using. Now I change the position of the direction control valve, and suppose this is the second position. Now what is happening in the second position? The pump is connected to the B end of the actuator, and the A end of the actuator is connected to the reservoir. Now what will happen? As the pressure will be developed by the pump, the oil will flow to the B end of the actuator, but oil will flow through this pressure compensated flow control valve. Now what is happening? As the oil is moving from here, the oil will go here, and from here through this, what you can say, the integral check valve, or I can call it known as the non-return valve, the oil will flow very easily. From in this direction oil can flow. So oil can be flow very easily, and the motion of the actuator will take place into the forward direction. So though I have provided here the flow control valve, but there is a one passage is provided through this integral check valve. The same amount of the oil, or the full amount of the oil, will go from here to here, and the actuator will move into the forward direction. Now what happening in the forward direction? Whatever the oil is stored here, that oil is freely moving. There is no restriction to the reservoir, and therefore the return stroke will be somewhat whether it will be slower or faster, as there is no restriction at the outlet, at the A end of the actuator. Yes, when the oil will move from this through this check valve, the return motion or the retardation motion of the actuator will be faster than the forward stroke. Understand? And in this way I control the speed of the actuator by just providing the pressure compensated flow control valve at the outlet of the actuator. Now you understand? In both the circuit I am using the flow control valve, but I am not just using the flow control valve, I am using the flow control valve with integral check valve. This is not return, and this valve plays very important role. You understand? And therefore when this end is connected, the oil will flow from here, and here freely the oil will flow, means 100% oil will flow to this stroke, and it will come to fast to this end. But when the this end, A end is connected to the pump, A end is connected to the pump. So what happens? As the piston will start moving, when whatever the oil is coming from this direction, the oil will not pass through this integral check valve because it is restriction. Okay, you can see here the oil has to pass through this flow control valve, and as this flow control valve I adjusted at 70%, 80%, 90%, it will have some restriction, and the forward motion of the what you can say, the actuator will be slower. So both the circuits, meter in hydraulic circuit, meter out hydraulic circuit, are used for controlling the speed of the actuator. Understand? Only the difference is that in meter in hydraulic circuit, the flow control valve is provided at the inlet, and in meter out hydraulic circuit the flow control valve is provided at the outlet of the actuator. Understand? So this was the meter out hydraulic circuit. Okay, boys, you understand the meter of out hydraulic circuit. Now we are going to see the third important circuit, which is known as the bleed off hydraulic circuit. Bleed off means what? To take away. म्हणजे थोडक्यात काय सांगायचं, ब्लीड ऑफ म्हणजे काय? काढून घेणे. लक्षामध्ये काढून घेणे म्हणजे काय? आपण काय करणार की ॲक्च्युएटरला जाण्याच्या अगोदरच थोडंसं ऑइल आपण अगोदरच काढून घेणार, आणि थोडंसं ऑइल अगोदरच काढून घेतल्यामुळे काय होणार, ॲटोमॅटिकली ॲक्च्युएटरची स्पीड काय होणार, कंट्रोल होणार. सो व्हॉट इज द ब्लीड ऑफ सर्किट? यू कॅन सी हिअर, ब्लीड ऑफ सर्किट इज नथिंग बट इट इज द बेसिक speed control circuit which is the replacement of meter in and meter out hydraulic circuit. Means when I want to control the speed at forward direction as well as the return direction, म्हणजे मला फॉरवर्डला पण स्पीड कंट्रोल करायची आणि मला रिटर्नला पण ॲक्च्युएटरची स्पीड कंट्रोल करायची. इन दॅट केस आय विल यूज द ब्लीड ऑफ हायड्रॉलिक सर्किट. अँड ब्लीड ऑफ हायड्रॉलिक सर्किट इज व्हेरी इम्पॉर्टंट as it can control the speed during the both the strokes of the actuator. Now we'll see the third important hydraulic circuit which is known as the bleed off hydraulic circuit. Now I will show you the diagram of bleed off hydraulic circuit. Now you have to identify which are the important components of the bleed off hydraulic circuit. Same components will be there, right? Now, and again very important question I want to ask here. So as I am uploading this video on the YouTube, there is a possibility that some students just click on the link and they will not watch the full video. So I once again request to all the students, watch the video or watch the lecture in one stroke from start to end. म्हणजे थोडक्यात काय, एकदा का तुम्ही लेक्चरचा व्हिडिओ सुरू केला तर केल्यापासून ते संपेपर्यंत एकाच वेळेस बघायचं, तुकड्या तुकड्यामध्ये बघायचं नाही. नाही तर 5 मिनटं बघितलं मग मी खेळून येतो, नंतर बघितलं 2 मिनटं बघितलं, असं बिलकुल करायचं नाही. कारण की लिंक तुटते, लिंक तुटली तर तुम्हाला काही समजणार नाही. अंडरस्टँड? देअरफॉर सगळ्यात महत्त्वाची गोष्ट, एकदा व्हिडिओवरती लिंकवरती चेक केलं की तो पूर्ण लेक्चर संपेपर्यंत तो व्हिडिओ बघायचा. त्याच वेळेस तुम्हाला ते सगळ्या गोष्टी काय होतील, लिंक लागेल आणि समजून येईल. दुसरी महत्त्वाची गोष्ट म्हणजे पहिल्या लेक्चरवरती कोणीही काहीही डिफिकल्टी विचारली नाही. याचा अर्थ सगळ्यांना समजला असेल किंवा काही जणांनी पूर्ण बघितलंच नसेल. तर वन्स अगेन आय एम रिक्वेस्टिंग टू वॉच द फुल लेक्चर, अँड इफ यू हॅव एनी डिफिकल्टी इन अंडरस्टँडिंग यू कॅन कमेंट मी ऑन माय पर्सनल व्हॉट्सॲप number. So that is important. And third important thing is that whatever the attendance today I check, though the views to the video is more, बघितलं बऱ्याच जणांनी, but attendance is very very less. And please remember that this your attendance is going to count. Therefore whenever you watch the full video you have to send me the attendance by saying present and watch the full video. That will be the attendance. I am recording all your attendance. Those who are sending me present, all this attendance is going to be recorded. Understand? So this is important thing and this is for your benefit. Now let us move to the important third. Tiwari and Chavan, the CR of the both the classes. तुम्ही दोघांनी सगळ्यांनी लक्ष ठेवायचे आणि सगळ्या मुलांना समजून सांगायचे किंवा सगळ्यांनी हे व्हिडिओ आपले लेक्चर ऐका, आणि काही अडचण असेल तर सरांना पर्सनल व्हॉट्सॲप नंबरवरती विचारा, किंवा ॲज यू नो दॅट यू कॅन कॉल मी ऑल्सो. तुम्ही मला फोन पण करू शकता आणि फोन करून पण विचारू शकता काय डिफिकल्टी आहे का नाही. कारण की ह्या सगळ्या लेक्चरवरती मग मी आता पुढे तुम्हाला एक असाइनमेंट देणार आहे, अँड दॅट असाइनमेंट यू हॅव टू कम्प्लीट विदिन अ शॉर्ट पिरियड ऑफ टाईम. अंडरस्टँड? ओके, सो लेट अस सी our third important circuit which is known as the bleed off. Bleed off म्हणजे काय? What I told you that bleed off means काढून टाकणे. So I will take out some oil before it going to the actuator. That is known as the bleed off circuit, and bleed off circuit is used for controlling the speed in the what? Both stroke. Yes, both stroke, forward as well as return. Correct. तिवारी ने एकदम सही आंसर दिया. क्या तिवारी? Okay. Okay boys, this is our bleed off hydraulic circuit. As you know that the components very well known to you. So what is this? Yes, this is reservoir, oil is stored. What is this? This is filter. The oil is filter oil. What is this? The pump unidirectional, right? Constant flow hydraulic pump. This is the prime mover electrical motor. Then you will go come here. This is the, now this is pressure relief valve. This is pressure gauge which is measuring the pressure. And you can see here there another one line is there. This is interesting. This is new thing. Before going to the pressure relief valve or before going to the system, I have connected one line, and here I have provided the flow control valve. And this flow control valve is nothing but, it is the, you can see this arrow, pressure compensated flow control valve. And whatever the oil is coming from this flow control valve, it is going to the reservoir. This symbol is nothing but reservoir. Here this valve also can be called as bleed off valve. But bleed off valve is what? Nothing but it is the pressure compensated flow control valve. So this is the difference in bleed off control valve, that the flow control valve is provided at the pump itself, right? In pressure line of the pump it is provided. Now here when I move forward, what is this? Yes, what is this? 1 2 3 3 boxes. It means it is 4/3 direction control valve. So there are the 3 positions. This is position number 1. This is central position, as you know, and this is the third position of the direction control valve, and this direction control valve is there. So it is the 4/3 direction control valve. So 4 means what? It is having 4 port, P A B R, P A B R, P B A R. So this is 4/3 direction control valve, and this is double acting hydraulic cylinder, right? So this is the actuator. Now what happens? The diagram is very simple. What happens? Suppose I started the pump, I started the motor, and the hydraulic circuit is on now. So what happens? Suppose this is the first position. Here in the direction control valve is here. So here what will happen? The P port is connected to the A port. So oil from the pump will go to the A port, right? And the B port will be connected to the reservoir. So from this B port, the oil will come to the reservoir in this first position. You understand, right? Now what happening? As I started the pump, whatever the oil is coming from the pump, that oil before going to the direction control valve here, some of the amount of the oil is already taken out by this flow control valve, means bleed off valve. What I said in Marathi मध्ये मी तुम्हाला सांगू ना, काढून घेणे, बरोबर आहे ना, टेक अवे. म्हणजे मी काय केलं, सिस्टीमला जाण्याच्या अगोदरच थोडंसं ऑइल इथून त्या फ्लो कंट्रोल वाल्व मधून काय केलं, काढून घेतलं. नाउ व्हेन आय टेक आउट द सम अमाउंट ऑफ द ऑइल थ्रू दिस फ्लो कंट्रोल वाल्व before going to the direction control valve, automatically what will happen? The amount of oil going to this A port will be less, and as the amount of oil will be less, the speed of this actuator can be reduced. Now suppose what happens, I put this flow control valve at 50%. It means what? Whatever the oil is coming from the pump, out of that oil, 50% oil will be taken here, right? Only 50% oil will go to the actuator, and due to that what will happen? The speed of the actuator will get reduced, okay, because I am taking oil already here, and therefore the speed of the actuator can be controlled here. That this opening you can change, the adjustment of the flow control valve you can do, and here you can see one difference. There is a no check valve, or there is a no non-return valve, there is a no integral check valve is provided, only simple pressure compensated flow control valve is there. Understand? So as I will take out some amount of oil here, when the remaining oil will go to the from P to the A port, the forward motion of the actuator will take place, and that motion will be get controlled, and that control of the motion will depend upon this setting, how much flow control valve I am setting. Understand? And from this return line, the oil will come to the return line, it will go to the directly, it will go to the reservoir. So right, return, there is no flow control valve. Now what happens when I change the position? Suppose this is position number 1, I change the position number 3 directly. This central position will look later on. So I came to here. So what is happening in this position? the pump is connected to the B port of the actuator, means the pump will be connected to the here, and A port of the actuator is connected to the reservoir. Understand? So oil will going to the from P to B. So when the oil will start moving from again pump to here, again some amount of the oil will taken outside here to the reservoir. So what happens here also, I am providing the flow control, same amount of the oil I take here. So when I will take that same amount of the oil, the remaining or less amount of the oil will go to the through this port, and again in this direction also, when the actuator will move from B position to the A position, its speed will also get controlled. Understand? And from this A port, the oil will come to the A port and it will go to the reservoir, right? So there is no restriction to the oil flow. So this is the basic bleed-off circuit. Understand? So by using the bleed-off circuit, you can control the speed of the actuator in the both the direction, in forward direction as well as in the return direction. And how that is controlled? That is controlled by taking away some amount of the oil that is coming to the through the pump before it entering into the direction control valve or before it entering into the actuator. So this is the bleed-off hydraulic circuit, and this is third position. Suppose I set the direction control on the third position. So what will happen in third position? P is connected to the R. So system is not stopped. I will not stop the pump. So pump will go on running. From here also some oil will come to the reservoir. Whatever the oil will go into the forward direction, that will come again to the reservoir. A end of the actuator is closed, B end of the actuator is closed. So in this position, what will happen? Whenever there is a position of the piston is there, the actuator will remain at that position. So there will not be any forward, there will not be any reverse motion of the actuator. And this circuit, we call it is known as the bleed-off hydraulic circuit. Please remember that the use of bleed-off hydraulic circuit is used for controlling the speed of the actuator in the both the direction, in forward as well as in the forward as well as in the return direction. Correct? You understand? So we completed the three basic hydraulic circuit. These three basic hydraulic circuits are known as the flow control hydraulic circuit, because we are controlling the speed of the actuator by controlling the flow of the hydraulic oil going to the actuator. So what we seen? First we seen meter in hydraulic circuit, where the flow control valve, that is the pressure compensated flow control valve with check valve, was fitted in the inlet of the actuator. Second we seen meter out hydraulic circuit. Meter out hydraulic circuit. In that meter out hydraulic circuit, what we did? We provided the pressure compensated flow control valve with integral check valve at the outlet. And third, that is the bleed-off hydraulic circuit. Here we have provided the simple flow control valve at the pressure line of the hydraulic pump. I hope you understand these three hydraulic circuits, which are known as the flow control hydraulic circuit. Tomorrow we are going to see again few circuits that are known as the sequencing hydraulic circuit. Now when I want to control the number of actuators, means here in three circuits, how many actuators were there? Only one actuator, right? Now suppose I have the application or some machine, and in that machine there are the two actuators are there, and that two actuators I want to control simultaneously or in a particular sequence. So for that reason, there is another one type of the circuit which is used, and that circuit is known as the sequencing hydraulic circuit. That sequencing hydraulic circuit we will see tomorrow, right? So at the same time, I will post the video on the YouTube. You all have to watch the video. Complete lecture you have to listen and watch. And if you have any difficulties, you have to ask me the questions. And after finishing the lecture, you have to answer my one question, that during my lecture I have taken the two names of the students. So after watching the video, you have to reply me P present, okay, and with that present you have to apply me the you have to send me the names of that two students which I taken in the whole lecture. So that is the test. वेदर यू हॅव वॉच द फुल व्हिडिओ ऑर नॉट. आलं का लक्षामध्ये? म्हणजे थोडक्यात व्हिडिओ तुम्ही बघितल्यानंतर उद्या तुम्हाला प्रेझेंट तर लिहायचंच आहे, पण त्याचबरोबर तुम्हाला मी पूर्ण लेक्चरमध्ये 2 विद्यार्थ्यांचे नावं घेतले, त्या विद्यार्थ्यांचे कोणाकोणाचे नावं घेतले ते तुम्हाला मला व्हॉट्सॲपवरती पाठवायचे आहेत. यूट्यूबच्या कॉमेंटवरती विद्यार्थ्यांचे नावं लिहायचे नाहीत, नाहीतर ते सगळे तेच कॉपी करतील, एकच कॉपी करतील. आलं का लक्षामध्ये? तसं करायचं नाही. ओके, गुड नाईट.